All right, so we are talking 10.5, day one of 10.5, and specifically we're going to talk today about recursion. So recursive sequences is the topic for today, recursive sequences. And I'm going to start us off by talking about this very first one, probably the most famous recursive sequence out there, called the Fibonacci sequence. Nice little Italian name there, Fibonacci. It's kind of fun to say. Since you're muted, you can probably say it in your room. So Fibonacci sequence is an example of a recursive sequence. And again, this is probably one of the most famous ones. So without telling you guys, I want to see if you can figure out the pattern. All right. So it's like a nice little puzzle here. So if you think you know the next few terms, go ahead and put it in the chat. We got 1, 1, 2, 3, 5. What would be the next few numbers? Go ahead and put in the chat if you think you know. Ooh, okay, okay. Wow, all right. Some of you guys already got it. Nice. Seeing if there's any more. People still thinking, figuring it out. Nice. So far, everybody? Okay, all right. Interesting. Okay. Those of you guys who got it, I'm curious, did you know this answer already or did you figure it out? Type that in the chat. Did you know it already or did you figure it out? Oh, okay. All right. So there was a mix. There was a mix. Okay. Okay, I think Gio was the first one who said he figured it out. Gio, how did you figure it out?
I added the first two terms and then I added the next two terms. So I did 1 plus 1 and then 1 plus 2 and then 2 plus 3 and then 3 plus 5 and then 5 plus 8 and so on.
Good. All right, keep going, keep going. And then how do I get to the next term?
13 plus 8, which is 21.
Keep going.
And then 21 plus 13 is 34.
And
then 34 plus 21 is 55.
Perfect. Dot, dot, dot. Nice, nice. Okay, so guys, that is what we know as a recursive sequence. Now, the reason why it's called a recursive sequence is because each term you get is used or is found by using the previous terms. That's why it's called recursive. So to get to the next term, you have to use the previous terms to get there. That's what makes this a recursive sequence, okay? So there's always two parts to a recursive sequence, okay? One is that you need to get the first few values, right? You need like a starting point. And then there's going to be a second part, which is the equation telling you how to use those previous parts to get to the next few terms, all right? So for example, if I were to write the Fibonacci sequence, right? If I were to write it in this form or a formula for it, I would write it like this, okay? A sub 1 is 1, all right, that's the first term. A sub 2 is also 1, okay? And then A sub n plus, should I do that? Yeah, I'll do A sub 1 plus 1 is equal to A sub n plus A sub n minus 1. That's how I would write the equation. Now, you might be wondering like, whoa, where did that equation come from? Okay, so let me explain. Let me see if I can outline this out for you guys. So when you have like A sub n, right? Like A sub n is just a term, right? Like a term. If you want to find like the one after, that would be A sub n plus 1. So one term after this like initial term, okay? If you want two terms after, then it would be a sub n plus 2, like 2 terms after. All right. So that subscript tells you like how many terms away you are, right? If I want like to use terms before, I would do a sub n minus 1. So that would be 1 term before this initial term. All right, if I want 2 terms before, you can do a sub n minus 2. So that would be 2 terms before, okay? So that's what all this like a sub n, n plus 1, etc. is for. So in fact, you might actually, let me rewrite this. There's another way you can write this that might be a little more intuitive. Maybe I can rewrite this as a sub n is equal to the previous term plus the previous term, right? So you can write it like that. All right, so different ways you can write it. Originally, I had this one, which means the same thing. Or you can even write it as a sub n plus 2 is equal to a sub n plus 1 plus a sub n. So there, it's just, there's a lot of different ways you can write it. Okay, so it's just kind of getting comfortable with the like the subscripts. I think that's probably the hardest part of this. It's just kind of getting used to these subscripts. Okay, so any questions though? Because once I think you get that, it becomes pretty straightforward. So any questions, put in the chat. What's the difference between a sub n plus 1 and a sub 2? Ooh, good question. Yeah, so a sub n plus 1 means the term after a sub n. A sub 2 is specifically the second term. So this one, the first one, is just more general, right? It's just the term after whatever you set as a sub n. Like if a sub n is a sub 3, then a sub n plus 1 is a sub 4. If a sub n is, let's say, the 10th term, a sub 10, then a sub n plus 1 is the 11th term, right? So this just means the next term. Whatever term you're looking at, it can be any term. This a sub n plus 1 is just the next term. Does that make sense, person who asked? Okay, cool. Good question. Nice. I like that. All right, let's try this out. So number 1, find the first 5 terms of the sequence described. All right, so we want the first 5 terms. All right, they give us the first one for free. So a sub 1 is just 4. And then they give us this formula right here. So a sub n plus 1 is equal to a sub n plus 7. Okay. So I want to, so using that formula, right? This just tells me that to get to the next term, right? I take the previous term and add 7 to it. That's it, right? I just take the previous term and add 7 to it. So if I want a sub, if I want a sub 2, that means this is 2, right? N plus 1 is 2, right? Which means n must just be equal to 1, right? So that's my previous term plus 7. All right, so that means my previous term was a sub 1, which is 4, plus 7, which gets me 11. All right, so a sub 2 is 11. All right, to get to a sub 3, all right, if I want this to be 3, That means n must be equal to 2. So that's my previous term, which is a sub 2 plus 7. So a sub 2 I found was 11. Add 7, and I get 18. All right, and hopefully by then you kind of start seeing the pattern, right? So a sub 4 is the previous term, a sub 3, plus 7. So that's 18 plus 7, which is 25. And a sub 5 is the previous term, a sub 4, plus 7. So 25 plus 7 gets you 32. All right, so your final answer would be 4, 11, 18, 25, and 32. Final answer. All right, and that is how you figure out a recursive sequence. Okay, let me see if there's any questions. Go for it. Questions. Number 2. Okay, so number 2, notice they give you the first 2 terms. All right, they give us the first 2 terms. So I got a sub 1, which is 3, and I have a sub 2 is -5. Looking at the formula that they give me, the equation here, I'm reading this as, to get to the next term, I'm going to do -4 times the previous term plus the term before that. Okay, so I'm going to have to go 2 back on that last one. All right, so let's see if we can figure this out. So a sub 3 then is equal to -4 times the previous term, a sub 2, I don't need parentheses, plus the previous term, or the one before that, which is a sub 1. Okay. So if you kind of liked subbing in the values, you can also think of it as, well, this is n plus 1 must be equal to 3. And if n plus 1 must be 3, because we're looking for the third term, that means n has to be 2, which means n minus 1 has to be 1. So that becomes a sub 3 is equal to -4 a sub 2 plus a sub 1. Okay, so you can think of it like that if that's easier. Okay, so from there we can start plugging in these values. So a sub 2 they give us is -5, and then a sub 1 is 3. So that gets me 23. Okay, I'm going to start calling on people, so get yourself ready. I'm going to ask you to help me find a sub 4 and a sub 5. Okay, so go ahead and start looking while I erase to give you some room, hopefully. Okay, Maddie, I'm going to call on you. Do you want to give this one a try? A sub 4? What do you think?
Sure. Okay, so the first step you would do I have to write out the equation first, or can I just go straight into like putting in the numbers and plugging that all in?
Since it's new for everybody, let's just do the previous step just to help everybody else.
Okay,
Yep.
so it'd be -4 times a sub 3 plus a sub 1.
Oh, close. So what's the one previous?
Oh, a sub 2?
There you go. Yes. Good. Okay. And then go from there.
-4 times 23 plus -5 or -5.
Perfect. Yes. All right. Excellent. And oh dear. Okay. Mental math. On a Monday, -4 times 23, -92 minus 5, -97. Okay, Maddie, can you just verify that that's right?
That's what I got when I put it into the calculator.
Perfect. Okay, and somebody verified in the chat. Perfect. Thank you. Thank you. Okay. Nice. Thank you, Maddie. Excellent job. Excellent. All right. Let's go a sub 5. Let me call on somebody. Help me with this one. Let's go to Michael. All right, Michael. A sub 5. What do you think?
So it's gonna be -4 a sub 4 plus a sub 3
Good.
equals -4 times -97 plus 23.
Perfect. Good. Um -4 times -97, positive 388
Yeah, that's what I got.
plus
So then
23
401.
401. Okay, thank you. Oh my goodness. My brain was about to explode. Okay, so nicely done. Awesome. All right, so final answer. There it is, guys. We got 3, -5, 23, -97, and 401. Final answer. Awesome, awesome job. Okay. Oh, wait. Sorry, my answer key said something different. I got 411. Did we do something wrong? 388. Oh, yeah, 411. Sorry. I think I just wrote it wrong. Okay. Final answer. There it is. All right. Any questions? Any concerns? You can plop them in the chat. That was definitely a little bit trickier since we had 2 previous terms to work with. So good job, guys. Nice, Michael. Okay. If you have questions, keep typing, keep putting in the chat. If not, I'm gonna let you guys tackle this last one. It's a little bit tricky, but I'm gonna see if you guys can handle it. This one is still find the first 5 terms. The tricky part is this guy right here, minus n. So I'll give you a little hint. Just make sure this n and this n match. All right, these are the same n's. All right, so try it out. Put your answer in the chat. Okay, go for it.
All right, so for the second term, I just did 6 times 3 minus 1 because we got the first term of 6, so we had to minus that 1.
Oh wait, sorry. So yeah, one more time. You did 6 times.
So I did 3. So I did 3 times 6, and since 6 is the first term, I minused 1.
Good. Yes. All right. So then it was 3 times a sub 1 minus 1. And like you said, it's 1 because this term needs to match that number. Good. So that is how you get the 17. Okay, keep going. A sub 3.
For the third term, I did 3 times 17 minus 2.
Good. All right. So you did 3 times the second term minus 2. Again, it's minus 2 now because those numbers need to match. And what did you get?
49.
Nice. Okay. And then a sub 4. Keep going.
So it will be 3 minus 3. So it'd be 3 times 49 minus 3.
Good. Which gets you
144.
perfect. All right. And the last one?
3 times a sub 4 minus 4. So then it'll be 3 times 144 minus 4.
Good. Which
428.
428. Perfect. Nicely done, Michael. Okay. So that one, yes, was definitely a little trickier because you had to change this last part. The minus n also changed as you increased your terms. Well done, Michael. Nicely done. Okay, questions on that one? Oh, you thought the 6 had to match the 6. No. If it was that, then this would have been a sub n as opposed to just n. Yeah, so if it was 6 minus 6, 17 minus 17, then this would be 3 sub a sub n minus a sub n. That's what that would look like. Yeah, but it was just n needed to match. Okay, glad that clarified that. All right, good. Other questions in the chat? Go ahead and put it down.